Alrighty, so today we are going to multiply and divide rational expressions. Remember, rational expressions are fractions with x in them. And we're going to multiply and divide, and this is actually very, very easy. It's going to be very similar to simplifying rational expressions, which we did yesterday, and the steps are very easy. So the first step is going to be factor. Like I said, for the next couple weeks, we're going to be factoring. So that's going to be factoring top and bottom. Then, just like we did with simplifying, you're going to cancel any factors that are common. These are factors that are common in the top and bottom. And lastly, we multiply across with fractions. So you're going to multiply anything in the top together that's left and anything in the bottom together. And that's it. So let's go ahead and start with this one. So you want to factor every possible thing that you can in the top and the bottom. This guy, a plus 2, that doesn't need to be factored. It's already a factor. So we don't need to factor that one. Okay? Let's look at this guy here. This guy is a subtraction. 4 is a perfect square, and a squared is squared, so this one's a difference of 2 squares. So let's go ahead and factor that guy. So we know difference of 2 squares is going to become 2 sets of parentheses, one's plus, one's minus, and then we do the square root of a squared to get the first number, so that'll be a. So this will be a and a. And then we do the square root of 4 to get the second number, which is 2. So this will be 2 and 2. So a plus 2, a minus 2. You might not have need to done the square root to get that part. So that's the first fraction in the top that we factored. This guy in the bottom over here, remember we said he doesn't need to factor. So we factored this, and this guy doesn't need to be factored. And then there's not really much factoring that can be done to 20a squared and 16a because those are just where they're at. But in a second, we'll rewrite those because we're going to look for common factors in the top and the bottom. So they only cancel if they're this common in the top and the bottom. So for example, you've got an a plus 2 here and an a plus 2 here. So those are going to cancel. Now, this 20a squared, we can rewrite the a squared. Remember what that means? That means a times a. So we want to do that because then one of the a's will cancel with one of these a's down here. And then 20 and 16, do those have a common factor? Yeah, 20 and 16 also have a common factor. So 16, they have a common factor of 4. So 4 times 4 is 16. And 20 is 4 times 5, right? So that common factor that those two have are going to cancel to the 4 and one of these 4s. So I'm going to go back and just remind you of what I just did one more time. So the first thing that I did was look for common factors. So we have a plus 2 and a plus 2 in the top and the bottom. Those cancel. Here we have an a, and here we have a squared. So remember, a squared is a times a. So we can rewrite that as a times a. And we can do that because then this a and one of those a's will cancel. 20 and 16 also have a common factor. They're both divisible by 4. So we can rewrite 16 and 20 as factors. So 16 is 4 times 4. And 20 is 4 times 5. And I'm choosing 4 and 5 and 2 and 10 instead of 2 and 10 because I want to cancel those common 4s. So I'm using that common factor. So the 4 will also cancel. So then the very last step is to then take everything in the top and put it together and everything in the bottom and put it together and just multiply across. So in the top over here, I have a minus 2 left. And the top over here, I have 5 times a. And then we multiply all this together. So 5 times a minus 2 will all go in the top. And then the bottom, the only thing I have left over here is 4. I don't have anything left over here, so I just multiply those together. 4 times nothing is just 4. And so then this is your final answer. So let's try number 2 now. So we're going to factor this x plus 4. It doesn't need to be factored. It will just stay. It's already a factor. So we'll go ahead and leave that alone. And we'll factor the other ones. Let's start with this guy down here because that's a trinomial with a equals 1. So we're going to look for two numbers that multiply together to get -8 and add together to get 2. So those numbers are going to be 4 and 2. One of them will have to be negative. If we make the 2 negative, we will get a positive 2 when we add. So this will be x plus 4, x minus 2. The top here, this is not a trinomial. It's just two terms. It's not a difference of squares, really, because of the x to the 4 there. So we're going to look for a GCF first. So if it looks like there's a GCF, that's, if you're not sure what to do, try to look for a GCF, greatest common factor. So these two have an x squared in common. So we're going to pull out an x squared first, and then write what's left. When we take out an x squared out of x to the 4th, we'll be left with x squared. And when we take out an x squared out of minus 9x squared, we'll just have minus 9. And then the same thing goes down here. That's two terms. That's not a difference of two squares. 6 is not a perfect square. So we're going to factor out a GCF. 2 and 6 are both divisible by 2, so part of our GCF is a 2. And then they both have an x in common, so factor out an x and a 2. And we're going to write what's left in parentheses. So when you take 2x squared and you take out 2x, you're left with an x. When you divide 6 by 2, you're left with minus 3, and you took out an x, so that's what's left there. Okay, so now we're almost ready to start canceling, but there's actually a little more factoring we can do. This x squared minus 9 here, that can be factored because that's a difference of two squares. X is squared and 9 is a perfect square. So I'm going to rewrite the fraction on the left here. This one's going to stay the same. But over here on this side, we have the x squared. The bottom's going to stay the same. But the top here, this is a difference of two squares, right? X squared minus 9. This is going to factor into x plus 3, x minus 3. Because difference of two squares is the exact same, except for the plus and the minus. You took the square root of x squared and minus 9. So now we can start canceling stuff out. So we've got an x minus 3 and an x minus 3 that will cancel. We've got an x plus 4 and an x plus 4 that will cancel. The x plus 3 is not going to cancel with anything. The x minus 2 is not going to cancel with anything. So that's all our common factors. So, and we can't cancel this x squared with this x, right? Because it would have to be the whole factor, x minus 2. So you can't cancel that. So we just write together what's in the top. Everything in the top gets multiplied together. So what's left in the top is x squared times x plus 3. And in the bottom, we have 2 and x minus 2, so we just put that all together in the bottom. Alrighty, so then we're going to divide real quick here, but this is also quite easy because the only different step is that you flip the second fraction and multiply when you're dividing. So you have to turn it into multiplication first. So you flip the second fraction and multiply. So the first step for number 3, because we're dividing here, all you're going to do is keep the first one the same. You're going to change the division to multiplication, and then you're going to flip this fraction over here. And now this just turns into a multiplication problem like we did above. So all we're going to do is factor this guy Stays the same, so you're not going to change anything about him. Can't really change the 12, so it stays the same. And the top here, we have a GCF we can pull out. That's not a difference of two squares. It's a sum. So, but we see an x squared, and 3 and 15 are both have a GCF. So 3 and 15 are both divisible by 3, so we're going to pull that out. They both have an x squared in common, so we're going to pull that out, and then we'll write what's left. So for this first part here, 3x cubed, when we take out 3x squared, we're left with, so we're taking out 3x squared. When we're left with that, we're just left with an x. When you look at 15x squared, divide that by 3, and we're just left with 5. And we took out an x squared, so that's all we're left with. So that's factoring out the GCF out of the top. The bottom is a trinomial with a equal to 1, so you're looking for two numbers that multiply together to be 4 and add together to be negative 4. So that's going to be negative 2 and negative 2. So the bottom will factor into x minus 2, x minus 2. Now we're going to look for common factors in the top and the bottom. Here we have x minus 2, but only one common factor gets to cancel with that x minus 2 since there's only one in the top. So you can't cancel out both of these, just one. There's no x plus 5 in the bottom, so it's going to stay. But we do have a common factor with 3 and 12. 3 and 12 are both have a common factor. What's their common factor? Well, it's 3. So if it's helpful, rewrite 12 as factors. So 3 times 4. And then you can cancel out that 3 in the top with the 3 there. And then since we're multiplying, we just take anything that's left in the top and put it together. So up here we have x squared times x plus 5. And then the bottom, we have a 4 over here. And then we just multiply everything in the bottom together. And so then x minus 2. So 4 times x minus 2. So everything in the bottom goes together and everything in the top goes together. And that's your answer. So we're going to do one more here. So again, the only difference between division and multiplication is you literally just, before you do anything with division, you flip the second fraction. So we're going to keep the first fraction the same. Change the division problem to multiplication and flip the second fraction. Now we'll factor. This guy will stay the same here. This is two terms. Then they have a GCF, so we'll go ahead and find the GCF there. So the bottom here will stay x minus 2. That doesn't factor, it's already a factor. And the top, we have a common factor of 5, because 5 and 25 are both divisible by 5, and an x, because we've got an x squared and an x. So 5x is your GCF. Factor that out, and you're left with x plus 5. And then over here on the right, we've got two trinomials. This first one, we're looking for two numbers that multiply together to get 12 and add together to get negative 8. Three and 4 multiply together to get 12, but that's not going to help us get 8. So 6 and 2 will help us get 8 if we multiply those together, but they have to add together to get negative 8, but multiply together to be a positive. So these are both going to be negative here. So the top will factor into x minus 6, x minus 2. So the bottom here, x squared plus x minus 20 is also a trinomial with a equal to 1. So you look for two numbers that multiply together to get negative 20 and add together to get 1, because there's a little invisible 1 here in front of the x. So 4 and 5 multiply together to get 20 and we'll add together to get 1, but we need a positive 1, so we're going to add negative 4 and 5 together. So this guy will factor into x minus 4, x plus 5 in the bottom. And now we're looking for common factors. So we've got an x plus 5 and an x plus 5. We've got an x minus 2 and an x minus 2. And that's all of our common factors. So then we multiply everything in the top together for our answer. So 5x and x minus 6. And then we multiply everything in the bottom together, which the only thing left here is x minus 4. So that is our answer. So now you're going to do your check for understanding. You can use your notes. If you need to phone a friend, you can, but you shouldn't have your phones out. Use your notes and use your neighbor, but no copying.